To my channel. Today's my lecture is Rankine cycle. What is Rankine cycle? Rankine cycle or vapor power cycles are widely used in the power plant such as coal field power plant and nuclear reactors. In this mechanism, the fuel is used to produce heat within the boiler, and the water is converted into the steam, and then they expand in the turbines. The work is obtained from the turbine. So this is developed in the 1859 by the William J.M. Rankine. This is a thermodynamic cycle also, and the heat energy is converted into mechanical energy, and the mechanical energy is transferred into the electricity by the help of electrical generator. So this is a boiler, this is turbine, this is condenser, and it is a water collector tank, and this is also pump. A boiler is used to boil the water, and therefore phase changes occur in there. The water is converted into vapor, and this is turbine. Turbines is used to produce work, to produce mechanical work, and this work is adiabatic expansion, reversible adiabatic expansion. And this is a condenser. Condenser are used to condense the vapor, and there is also the phase change occur in there. Vapor is converted into the liquid. In this phase change, water is converted into the vapor, and condenser vapor is converted into the liquid. And this is a pump is used to pumping process and transfer the water into the boiler, and the boiler will get again boil the water, and this process is also known as reversible because the water is converted to the liquid is converted to the vapor, and vapor is also converted into the water. This process is known as reversible. So in there 1 and 2 there is a turbine work, which is H1 enthalpy H1 minus H2. This is turbine work. And WP is a pump work, H4 yani H enthalpy 4 minus enthalpy 3. This is the pump work. Q1 is a heat supply to the boiler, H1 minus H4, and this is a Q2 heat is exit from the by the help of condenser is Q2 minus Q3. In there P1 yani pressure, this is enthalpy H1. There is a same in between boiler and turbine, and after turbine the pressure and enthalpy will remain change because some liquids are strike yani vapors are strike in the blades of turbines. There is also change in pressure enthalpy, and this is converted to P2 and H2. After turbine the vapor is transferred to the condenser to condense their vapor. The pressure is remaining constant, but the enthalpy will also change because they are also changing in phase change in their vapor is converted to the liquid. So there is also change in heat temperature. So their H2 is converted to H3, and again the pump is compressed the liquid and transferred to the boiler with the high pressure, and the pressure P2 is changed into P1, and enthalpy is also changed H4. So let's get start the points discussion about 1, 2, 2, 3 and 3, 4. So in there 1, 2 there is a reversible adiabatic expansion in the turbine, and 2, 3 at constant pressure there is no change in pressure. At constant pressure the heat is transferred to the condenser and condense the vapor into the liquid. And again 3 to 4 there is a reversible adiabatic pumping process by the feeding pump, and 4 to 1 again constant pressure is to remain constant P1 and P2, constant pressure, and transfer the heat to the boiler. And there is a TS diagram. We have to draw the TS diagram with the help of this mechanism of thermodynamic cycle. This is the diagram to help to draw the thermodynamic cycle. So let's get started. By the help of this thermodynamic cycle, we draw the TS diagram. First of all, we draw a vapor dome. There is a two pressure line, constant pressure line P1 and P2. This is 1, this is 2, this is 3, and this is 4. There is a liquid, there is a liquid plus, vapor plus liquid, and there is a superheated steam. In there 1 and 2, there is a reversible adiabatic expansion in there. 2 to 3, so there is entropy remain constant, no change. And 2 to 3, so 2 to 3, there is a constant pressure at transport of heat to the condenser. Condenser change their phase, vapor converted into liquid. So there is a vapor and liquid, and the liquid is in there. So the line is drawn like this. And 3 to 4, there is a change in pressure. There is also adiabatic expansion in there. So there is entropy remain constant. The line is drawn like this, and there is again pressure remain constant and transfer the heat to the boiler, and they transfer to the heat to the boiler. This is a reversible. This is also known as Rankine cycle. Again we repeat the diagram. This is a two pressure line. This is a vapor liquid dome, and P1 and P2, there is a turbine work. There is reversible adiabatic expansion. There is a no change in entropy, so there is a line is constant. And again 2 to 3, there is a constant pressure. This is a pressure line, this is constant pressure, and they transport the heat to the condenser. When the condenser transfer the heat, the vapor converted into the liquid. The liquid is in there, and in the pump, there is a adiabatic compression in the pump. Also entropy remain constant. The lines is drawn like this, and again 4 to 1, there is a constant pressure and transfer the heat to the boiler. After the TS diagram, we find the efficiency of Rankine cycle. Efficiency of Rankine cycle is a network upon supply of heat, yani Q1. What is the network of Rankine cycle? Work done by the turbine or minus by the work done of pump. In WT minus WP upon Q1. This is a network, and we have to calculate by the help of this formula efficiency of Rankine cycle. WT is H1 minus H2 minus H4 minus H3 upon Q1 is H1 minus H4, heat supply, H1 minus H4. These formula are used in the numerical cases of Rankine cycle. So thank you for watching this video.